Well, hello 3C, and welcome to Finding Sides with Primary Trig Ratios. This shouldn't be anything new. We did this last year, but we're going to cover it again just to make sure you understand what's going on. So take a look up here at our topic. It says finding side lengths with trigonometry, and our goal, I can use the three primary trig ratios to solve for side lengths in right triangles. So the first thing is, what are the three primary trig ratios? Well, we're going to review that here. These are the three: sine, cosine, and tangent. And I'm just going to go back over with what they mean. What they mean is anytime you have a right triangle, like I have here, I've got two right triangles actually, um, that if this theta, it has a value, let's say it's 50 or something like that, any triangle that has a 50 down here would have a 40 up here. And if there's a 50 down here, 40 up here, and 90 here, any triangle that has that in it, even if it's a great big triangle or a little tiny triangle, they're all similar, which means that if you have similar triangles, the side lengths are proportional. So anytime I have an angle here, I know that when I divide the sides, I get something that is going to be proportional no matter how big the triangle is. And your calculator stores all those proportionalities in it. So we have to know what the ratios are. So I'm going to click on these things. Sine is the opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over adjacent. Now, what do we mean by all of these opposite and adjacent and blah, 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 blah? Well, the first thing you have to know is that we always go by the angle. So down here, I've got angle theta marked, and this theta should have been up here because I wanted it in the opposite way. So in this one, we've got theta down here, and in this one, we got theta up here. And I'm going to erase these numbers because we don't need the numbers. We're just going to go by the angles. So we go by this angle. These three sides are going to be labeled either opposite, adjacent, or hypotenuse. Now here's how you tell the difference. First of all, as we learned with Pythagorean theorem, this points the way to the hypotenuse. So this side is the hypotenuse. Always, 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 always. If you've got a right angle, it points to the side that's the hypotenuse. Which means that we can actually do that one in here too. That is the hypotenuse. Now, from this angle, I'm going to label the other two sides. So if I go directly across the triangle from the angle that I'm working with, the one that I circled, this side is called opposite because it's directly across, which means if I go over into this triangle, this is the angle that I marked. That's where I put my theta. So the opposite side here, even though these two triangles are actually identical, I just cloned them. Okay, this side over here is called opposite because I'm talking about a different angle. So we always go by the relationship with the angle. And since the only thing that's left is adjacent, we're going to call this adjacent. Now, adjacent actually means next to. So this side is actually next to the angle that we're talking about. And so up here, this is adjacent because this side here is next to the angle we're talking about. Now the hypotenuse is also next to the angle we're talking about, but since it's the special side, it gets a special name, and we always call it the hypotenuse. So now we're going to use these three ratios to find a missing side length. And we're going to set them up as a ratio. So we need to know how to solve ratios the same way that we were doing in the first lesson from this unit. So we're going to find the missing side length. Now there's two missing side lengths here. There's this one and there's this one. So let's actually find them both. I'm going to start by finding this one. And I'm going to put a little b on it. And I'm going to put the little b on it because it's across from the big B. And this side length over here, I'm going to call little a because it's across from big A. Now, we're going to pick which one we're going to find first. When you're using the trig ratios, the first thing you should do is circle your angle. Circle your angle. Now that's going to be the angle you use, so it has to have a number on it, because using this angle over here would be perfectly useless to us. It does not have a number. So I'm going to use this angle here, and now after I circle the angle, I'm going to label the sides the same way I did up top. Label the sides. So here's how I label the sides. I'm going to do that in green this time. From this angle, well, first of all, let's put the hypotenuse. B, this side over here, this is the hypotenuse. And I'm not going to write it all out. I'm just going to use a big capital H for hypotenuse. Now, from this angle, if I go directly across the triangle, remember I get the opposite side. And then the only thing left over is A. Oh, look at that. Big A goes on little a. Okay. So, we got to figure out which we're going to find first. Are we going to find little a or little b? Well, if I'm going to find little a first, okay, we have to use the A side, okay, because that's the side little a is on. And then I can't use B. If I used B side, then I have an A and a B together, and when I have two unknowns, it doesn't work. So I have to use a side that has a number on it. So there's the number 12. So we say 52 degrees, and I have to use side A, and I have to use side O. Now, do you remember what the shortcut was for the three primary trig ratios when we have sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent? We use these letters. So, and these letters, ka, and then these letters, toa. And so ka toa is what you should have in mind when you're doing these things. So I'm just going to write ka toa. And these two things that I've circled, because I'm finding little a and I have to use a number, is A and O. And A and O are is in toa. So I'm going to put the T in front of here, and the T is tan. Now, tan is opposite over adjacent. So our opposite is 12, and our adjacent was our little a. Now, tan of 52, your calculator knows what that number is. It's just a number. Make sure your calculator says degree or has a big D in it, like mine does right here. Okay. Now I'm going to find out what that number is, tan of 52. So on my calculator, I have to type in 52 and then press tan. Some of your calculators, you'll have to do it the other way around. And I'm going to keep 4 decimal places because this is a nasty decimal. But if we keep it to 4 decimal places, that'll keep us fairly accurate. So 1.2799. So instead of tan of 52, I'm going to write in 1.2799. I hope that's what I said. 1.2799. Yep. This and this are the same number. And then we've got 12 over a. Now remember, when you're cross multiplying or solving by comparison or whatever, I like to do cross multiplying in these. If there's no number underneath a number, like say you just have one number that's not a fraction, you can always put it over 1. So now I'm going to actually use the cross multiplying approach on this one and say that this number times a, which is going to give me 1.2799, a is going to equal 12 times 1, which is just 12. And then I have to divide both sides by 1.2799 to get this a by itself. 1.2799. So now to get my a, I have to do this division. So doing that division, 12 divided by 1.2799. And that's 9.38. 9.38. So that side length is 9.38. Now I'm going to do little b. If I choose to do little b, okay, if I choose to do little b, I'm going to switch colors here. I'm going to go with blue. I have to use little b. So I'm looking at a side H this time. And I also have to use a side that has a number on it. And that is still the O side. Now, it's true that we actually do know what A is, but since I don't know if I got this one quite right, I'm not going to actually use it. Now, we're still using this number that we have here, this 52. So we're going to go 52 degrees. And I have to figure out whether I'm going to write sine, cos, or tan in front of that 52 degrees. So remember our SOHCAHTOA? We're looking at these two letters, O and H. Which one of these has O and H? I can hear you screaming. I know you're saying sine has it. There we go. So I got to write sine in front of there. And I'm going to put sine is O divided by H. That order, remember when I did it up here, I'm going to go up very quickly. Whoop. See up here? Sine opposite over hypotenuse. So we have to go opposite over hypotenuse. So it's going to be 12 over B. 12 over B. Now remember, sine of 52, the same as tan of 52, is just a number, and the calculator is going to tell me what it is. So I type in 52 and hit sine and equals. So 0.6, oh, I missed it, 0.61568. 61568. And that's 12 over B. We're going to put this over 1, and now we're going to cross it up. We're going to cross multiply. We're going to go this way, and that's going to give me 0.61568. I got 5 digits in there. That's fine. Is that what I needed? 61568. Yep, I just went a little farther than I needed. And then it's going to multiply B, so I just put the B with it. And then 12 times 1 if I cross it up the other direction. Okay, 12 times 1 gives me 12. And now I have to divide both sides by that nasty decimal, 0.61568, because that's going to cancel that out. That 0.61568 is multiplying the B, so to get rid of it, we divide it. 0.61568. Now, I'll be able to figure out what B is as soon as I type that into my calculator. So, 12 divided by 0.61568. And that tells me that it's 19.49. 19.49. And so we found both sides using trigonometry. Now, once I found one side, I could have used Pythagorean theorem to find the other, but we're practicing trig, so I didn't. Example number 2 says find the missing side length. Now, this is the last example, I believe. Yep, and then you got some homework questions from the textbook. So let's see how quickly I can go in. It says find the missing side length. Let's just do one side length this time. Let's find this one over here. Let's find sine little b. So if we're going to find side little b, again, we start by circling the angle that we're going to use. And then we're going to label the sides. Well, this points the way to the hypotenuse. So that's the hypotenuse. Across from the angle I circled is opposite, so it's the O. And then the remaining side is called adjacent because it's right next to, it's touching the 30. Now, if I'm finding little b, I'm going to switch colors here. If I'm finding little b, I have to use little b, and I have to use a side with a number on it. So this one over here. I don't need this at all. There's no number on it, and I'm not being asked for it. So we're going to use side O and side H. Now remember this, so, ka, toa. Well, O and H are with sine. So we're going to go sine, and 30 degrees has to go with sine because that's what we're going to punch into the calculator, equals opposite over hypotenuse. So our opposite is B, and our hypotenuse is 24. So sine of 30, I'm going to punch that into the calculator, 30, and hit sine. You might have to do it the opposite direction. Oh, look at that. That's a nice number, 0.5. So sine of 30 is 0.5 equals b over 24. Now this one is actually easier. We don't have to cross multiply because the b is on top. We can use isolation and just say, oh, I'm just going to multiply by 24 and that gets me my b by myself. But then I have to multiply by 24 on this side too. And so my answer, this side gives me the b, and this side 24 times 0.5, well that's like saying what's half of 24, and the answer there is 12. And that actually concludes this video. Give it a try yourself.